In this video, we're going to look at still integration by substitution, but where the substitution instruction is very different. So previously we were told to substitute u for an expression in x. Now you can see we're going to be asked to use this substitution where x is this. Now, there's a couple of ways you can do that, this sort of question, and let me just start with the first. I'll just call it the first way. We're going to do simply what it says. So we're going to take this integration, and instead of where there's an x, I'm going to write this a half. So we've got 2 times, instead of that x, I write a half times u plus 1. And I've got a plus 1, and it's all over the square root of 2 times the x. So it's that same thing again, 2 times a half times u plus 1. And underneath the square root this time is a minus 1. And there's a dx. Now, we're not going to integrate anything with u's in it and have dx written on the end. So, what can we get from this? The only thing we can do with this is we could differentiate this expression x, but with respect to u. And dx du is simply a half. Now, knowing that I've got a dx here, and I want to remove that, let's get an expression for dx. So I could get dx by itself if I multiplied both sides by du. So dx is du on 2. And so I can put that in now. dx is du on 2. Now, this needs a lot of tidying, and I think I'll take that half out. So remember, that is just du times a half, and when we've got a constant, we can take it out the front. So we've got a half times the integral. Tidying this up, you get u plus 1, because the 2 times a half cancels out. We've got u plus 1, which is u plus 2, over square root of 2 and a half cancel out. We've got u plus 1 minus 1, which is just root u. Now, we don't integrate a fraction, so what are we going to do? We could bring that to the top and call that u to the minus a half, and multiply it by u plus 2 du. And then what can we do? We can expand that bracket because we don't integrate a product. But we can multiply this in, u to the half times u to the 1, multiplying them, we add the indices, so that's u to the half plus 2u to the minus a half. And we need to integrate that with respect to u. They're 2 terms that we can integrate. Add 1 to the index, divide by the new index. I don't need square brackets because I'm not going to be substituting anything. And to get, add 1 to the index, a half plus 1 is 3 on 2, divide by 3 on 2 is the same as times by 2 on 3. Keep your 2, add 1 to your index, so it's a half, divide by a half is the same as times by 2. And tidy that up, we've got a half outside, 2/3 u to the 3 on 2 plus 4 u to the half plus a constant. So that's one way to do it. And, of course, there is another way. Now, it'll be totally up to you when you see this alternate method as to which one you use. So you might think in the beginning, well, they've said that x is that, but I'm really used to finding an expression for u, and I'm going to just manipulate this little thing that they've told me, this x equals a half u plus 1, and I'm going to see what u ends up being. Now, if I multiply both sides by 2, I'll get 2x, and I'll have u plus 1. And then if I think about, I've been, more familiar with getting an expression for u is 2x minus 1. Now, that is good. It's good for here because you can see 2x minus 1. You would replace what's underneath the square root with the u, which would get you to that spot there. So that's all good. We also need an expression for 2x plus 1. So from here and 2x, if I had to plus 1 to this side, then I've got a plus 1 to this side. So 2x plus 1 actually becomes u plus 2. So now I have an expression for the top. 2x plus 1 becomes u plus 2, which is what we had there. And the other thing that I have to get a replacement for is my dx. Now, what would dx du be? Dx du would be equal to a half. But I want an expression for dx. Multiply both sides by 2, so dx is equal to du on 2. So replace dx with du on 2, take the half out, and you get back to this line here. So we'd actually have that the integral becomes the 2x plus 1, which is u plus 2, over the square root of u, and dx is du half, take the half out, separate it and put it out here. So, which is exactly that line. So, there we got it by simply substituting our value for x straight into the expressions and tidying, and u came out. And here we got to that line by rearranging this back to the u's because we were used to u. Now, this will only work if when we manipulate that, we get one of these expressions, and probably that one under there is the one we want. So, I don't know, this one, I'm sure the questions will be set up such that this one will always work and without too much complication. So you probably are going to go with that. Now, I really apologise for being all over the place with the notes for this, but you would be right to do exercise 6D, questions 1, 2, and back in 6B, yep, I meant that. If you looked at question 10, maybe you won't go all the way to E, maybe A to D. You can see that they're suggesting that do some of those questions by substitution, so you could do those. I will put this next bit in a separate video which covers the rest of the questions in 6D.